What terms help us describe three-dimensional figures? In this lesson, you will learn how to identify the parts of three-dimensional figures by locating faces, bases, vertices, edges, and height. Before we jump into the lesson, I want to make sure we really understand what exactly a dimension is, because we're going to be talking a lot about three-dimensional figures. So a one-dimensional figure is a figure that has one dimension. A ray, a line segment, and a line, we can only measure their length. They don't have a width, they don't have a height, they just have one dimension. Two-dimensional figures, however, have a length and a width. If we look at a rectangle, we can measure its length and its width. Same goes for a triangle. It has a length and a width, and in fact, all polygons are two-dimensional or 2D figures. They have length and width. So, what is a three-dimensional figure? As you may have guessed, it is a figure with three dimensions, length, width, and height. This figure that you're looking at, it's kind of like a shoebox figure, has a length, a width, and a height. I should mention, though, that what you're looking at is a 2D representation of a 3D figure. If you can't hold it, if it doesn't occupy space, it's not really 3D. But since we only have a computer screen to work with, we're going to have to deal with 2D representations of 3D figures. Let's jump in and start defining that terminology. A face is any of the flat surfaces on a three-dimensional figure. In just a moment, you're going to see the faces fly in. They are the flat surfaces on this figure. Here they come. There's 1, 2, 3, 4, 5, and 6. This 3D figure has 6 faces or flat surfaces. Next, let's talk about what an edge is. An edge is where two faces meet. Here you see an orange line segment that represents an edge. Two faces meet at that edge. Here's another example, a longer edge, but still two faces meet there. There are additional edges on this 3D figure, but we're not going to worry about that for now. Let's continue looking at the terminology. A vertex is a point where three edges meet, and vertex has sort of a funny plural form. The plural of vertex is vertices. Here's an orange vertex, and as you can see, it was a yellow vertex, and 3 orange edges meet at that vertex. Here is another yellow vertex, and 3 orange edges meet right there. There are other vertices on this 3D figure, but we're not going to worry about them for now. Next, we want to talk about what a prism is. And a prism is a special three-dimensional figure. It always has 2 parallel, congruent, polygonal bases. This is an example of a prism, and we would call this a pentagonal prism. The reason we call it a pentagonal prism is because it has a pentagon base on top and a pentagon base on bottom. The 2 pentagons are parallel and congruent, and as you probably know, a pentagon is an example of a polygon. So this pentagonal prism has parallel, congruent, polygonal bases. Here's another example. This is a triangular prism. The 2 triangles represent the bases, and they are parallel, polygonal, and congruent. Right here we have a pyramid. A pyramid is not a prism because it has only one base and a vertex where those edges meet. The final term that we want to define is height. And the height is the distance between a prism's bases. We're going to look at this pentagonal prism one more time. There are its 2 parallel, polygonal, congruent bases. And right now you're seeing some red edges. Those edges represent the height, the distance between the prism's bases. And height is always going to be perpendicular to a base. So there's lots of different edges that represent the height on this particular prism and on any given prism. In this lesson, you have learned how to identify the parts of three-dimensional figures by locating faces, bases, vertices, edges, and height.